let's look at section 11.1. We're going to keep on going with some notes. So I want you to get these basic properties into your notes. These are properties of limits. So we're going to start with the fact that b and c are real numbers, okay? And n is a positive integer. So I'm going to explain that as we go. The first limit principle or property says as a limit as x approaches c. So remember, c is just a constant. So an example would be the limit as x approaches 4, and then b is also a real number of 3 equals 3. It's going to equal 3 because if you think 3 is just a function, it's the line y equals 3. This is a horizontal line. So no matter where you go, your intended height is always going to be 3. If you move that line up to 5, your intended height is going to be 5. So that's why the limit as x approaches 4 of 3 equals 3. For number 2, you have the limit as x approaches c of x. So if you think of that function, here it is. So no matter what x value you pick, your y is going to be the same. So that's why it'll equal c. So just a few more here. You have the limit as x approaches c of x to the n. N is a positive integer. So if you think of, say n is 2, you're going to get a parabola. So then this is just going to be c to the n. So let's look at that. The limit as x approaches, let's do 4 of x squared. So if you think about this, x is approaching 4, so your y value, a parabola, has all real values. It's just going to be 16, okay? And 16 is 4 squared, so that's how we got that one. And then the same holds true with square roots. There are a few properties. All of these you can get by substitution, though, and we're going to look at that in just a second. So here are a few more properties of limits. Same rules apply. B and c are real numbers, n is a positive integer, and we're going to look at two separate functions. We'll look at the function of f and the function g. Basically what this says is if your function is multiplied by a constant, your limit is just the limit value multiplied by that constant. We're also going to see that we can add functions together, or we can split them back up, but the limit is still going to be the same. That holds true for multiplication as well, division, or for your quotients, and power rules, your limit would be raised to that power. It's a little confusing when it's abstract, but you'll see some examples as we continue on throughout the section. There are a few ways to solve limits. We've already looked at graphing a little bit, and we've spent a lot of time looking at tables. But today, we're going to look at direct substitution. So let's get a pretty color. Maybe. This is a pretty purple. So direct substitution is the process we're going to use. And we've talked about this a little bit in class so far. So let's look at these examples. If you have the limit as x approaches 4 of x squared, oh, we just did this one. If you substitute 4 in for x, you'll get 4 squared, so the limit equals 16. Now you can prove this by looking at your table. No matter how close you get to 4 from the left or from the right, your values are going to approach 16. And if you put 4 in on your table, it's also going to be 16. So the intended height is 16. So for b, you have the limit as x approaches 4 of 5x. This is just a line, okay? So go ahead and substitute 4 into x, and you'll get 5 times 4, which is 20. So when you can use direct substitution from now on, you don't have to make the table. For c, you get the limit as x approaches pi. Now don't be scared, pi is just 3.14159, and it keeps on going, right? So we can substitute it in. Tangent of pi is actually 0. And then substitute pi in down here, so you get 0 over pi, which equals 0. So the limit of that function as x approaches pi is 0. For letter b, you've got the limit as x approaches 9 is the square root of x. So what's the square root of 9? 3. So the answer to D is 3. For E, you've got the limit as x approaches pi, so another one with pi in it. X cosine x. So substitute x in, or pi in for x, and you'll get pi cosine pi. Well, cosine of pi, so that's cosine of 180 degrees is -1. So it equals pi times -1. So just negative pi is your answer. All right. Hopefully you're doing good so far. Let's look at F. So F is a power one, but we can just use substitution. So if you substitute 3 in here, remember order of operations, you're going to get 7 squared, which equals 49. So if you were going to make the table for that, if you were looking either side of 3 from the right or the left, getting super close to 3, your value should get closer and closer to 49. This is a continuous function. So that's why we can use substitution. There's no holes, no nothing. All right, so that brings us to the end of the lesson. So we looked at some properties, which are going to be very helpful for us, and we'll explore some of them in class. But I want you to try a few problems. I want you to try substitution ones. It's actually going to be on page 759 in your book. I want you to do 53 to 67, odd. I'll put an image to all these problems in It's Learning too, in case you forgot to bring your book home over the weekend. I'm giving you the odds. If you have your book, I want you to be able to check your answers. Some of them are going to be fractions and some of them are going to be super long decimals. But for every single one of them, you're going to use substitution. So no more tables, no more graphs. Substitute your values in. All right.